Hello, in today's lesson we will be looking at gravitational forces. Before we begin, the structure of the video will be as such. Firstly, we will recap on what forces are and the types of forces. Next, we will look at gravitational forces. We will try to understand what is it, the factors that affect it, and then we will look at the difference between mass and weight. So these are the questions that you will be able to answer by the end of today's lesson. And if you are still unsure about how to answer these questions, then I would suggest watching the video more than once. Alright, so firstly, as we have learned before, forces are a push or pull that can cause certain effects. So there are 4 effects of forces. So by now you should know what these 4 effects of forces are, and I will write them here just for you to remember. So firstly, they can start or stop motion. Secondly, they can change shape or size of object. Third, they can increase or decrease the speed of moving object. And then lastly, change the direction of motion. Alright, so the next question that we have to ask ourselves is, what are the different types of forces? So we have 4 different types of forces here: frictional, magnetic, elastic force, and gravitational force. And they are categorized into 2 big groups, which are contact versus at a distance. So if you have looked back on your work, you will be able to identify which forces belongs to which group and be able to define what these forces are and where they take place. Alright, so today we will be focusing on the 4th force, which is the gravitational force. So by the end of today, you'll be able to define and explain what gravitational force is. Alright, so firstly, let's move on to gravitational force. So what is gravitational force? So I would like you to try this out. Try jumping. Do you find yourself falling back to the ground? So is there something that is pulling you back to the ground? And based on this, I would suggest to you that the reason why you are pulled down back to the earth or to the ground is due to gravity. We say that there is a gravitational force between your body and the earth. Alright, so you see the earth here, and then you can see yourself over here. So the gravity actually keeps you rooted to the ground. It's the reason why you are not floating around in space. Alright, so this, if there is no gravity, this will happen. However, because there is gravity, you are being pulled to the ground. So then, what is gravity? So gravity is a force of attraction, but it's not just any force of attraction. It is a force of attraction that exists between things that have mass. So now let's take a look at this. Alright, we have the earth, over here, and then we have you. Alright, so both you and the earth are made of matter, and hence you have mass. So if we are to recap our topic on matter, matter is whatever that has mass as well as volume. So therefore, if you have mass and you occupy space, then you are made of matter. So look back at our definition here. Gravity is a force of attraction that exists between things that have mass. So over here, we have, you have mass because you're made of matter, right? The earth also has mass. And because of that, there is a force of attraction between you and the earth that keeps you rooted to the earth. Alright, so moving on. What affects gravity? So, is gravity the same wherever we go? The answer is no. The amount of gravitational force is dependent on the mass of objects as well as the distance between the two objects that we are talking about. So firstly, let's talk about the first factor that affects the gravitational force. It is the mass of the objects. So to recap, mass is the amount of matter that is in an object. Amount of matter that is in an object. So the relationship between mass and the amount of gravitational force is that the larger the mass, the greater the gravitational force between the two objects. So larger the mass, greater the gravitational force. And the opposite is true. So if the mass is lesser, then the gravitational force will be less. Alright? Now let's take a look at an example to explain mass. Why are astronauts able to jump so high on the moon? But when we jump on the Earth, we are pulled back down. So let's compare the Earth and the moon. The picture that we have here is of the Earth and the moon and their sizes. Which is bigger? That is correct. The Earth is indeed bigger compared to the moon. So therefore the Earth has a larger mass. It contains more matter than the moon. So remember, look at this. It has a larger mass, right? And based on our definition just now, if it has a larger mass, there will be a greater gravitational force. So this over here explains what I went through just now. The larger the mass, the larger the gravitational force, and therefore the stronger the force of attraction. So imagine this. You are located here. Because the Earth has a larger mass, the force that is pulling you down is larger. However, because of the smaller mass of the moon, the force of attraction between you and the moon is much weaker as compared to that on the Earth. Alright? So you might be wondering, is there gravitational force between my bed and I, since both of us have mass? The answer is yes. But because the mass of the two objects are very small, the gravitational force is very, very, very small as compared to the examples that we have looked at here. Alright, so now let's take a look at the second factor that affects gravitational force. So this is our second factor. Alright. So when I mention distance, what do I mean? Is how far or how near. So how do we explain how distant affects the gravitational force? This text in orange here explains it to you. How far or close the two objects are affects the amount of gravitational force between them. So the relationship that we see is that the closer the two objects are, the greater the gravitational force. Alright, so this is a relationship that is very important that you need to remember. So if the closer the two objects are, they will have greater gravitational force. So if they are further away, the gravitational force will be weaker. Yes. So then you might be wondering, why doesn't the moon then crash into the earth? Like we mentioned just now, gravity is the force of attraction between two objects, right? So in that case, why doesn't the moon move towards the earth? Because of the gravitational force that is acting on the moon. Well, the explanation is simple. The moon and the earth are located very far apart. Therefore, the gravitational force between them decreases or is quite weak. So that is the reason why the moon does not crash into the earth, because further away equal weaker gravitational force. So therefore, remember this. However, I must note to you that at this level, the explanation that you're required to remember would be this explanation here. However, as you go further in your science journey, you will learn about this thing called velocity. So that is also another factor which explains why the moon does not crash to the earth. However, it is enough for you to know this because this is what is required of you at this level of science. All right? So then, we have talked about the two factors that affect the amount of gravitational force. So firstly, we have mass, and then we have distance. Remember, the relationship is the greater the mass, the stronger the gravitational force. The further the distance, the weaker the gravitational force. So do remember these two factors that affect gravitational force. Alright, now we move on to the next part of the video, which goes on to explain mass versus weight. Are they the same? Well, as we have learned in our topic of matter, mass is described as kg, right? And then weight, as we know, is also kg. However, they are not the same. Let's look at their definition. The definition of mass is the amount of matter that is in an object. However, the definition for weight is how heavy the object is. So the weight of an object is determined by the amount of gravitational force acting on it. However, the mass does not change regardless of where you are. So if you are on the moon or you are on the earth, your mass will remain the same, but your weight will change because the gravitational force is different on the moon and the earth because they have different mass. Let's look at an example, right? So object P has a mass of 300 kilograms, so it weighs 300 kilograms on Earth, but weighs 150 kilograms on the moon. Why did its weight change? So we see here that it has a mass of 300 kilograms, but then the weight is different on Earth and on the moon. As we have explored just now, the amount of gravitational force on the Earth and on the moon is different. Therefore, because there are different gravitational force in these two areas, their weight will change because weight is affected by the amount of gravitational force acting on an object. Alright, so since the moon has a weaker gravitational force compared to the Earth, the weight of the objects will change. However, on both the moon and the Earth, the mass remains the same. So an easy way for you to remember this is by envisioning objects as being made of these green circles. So these are the particles which objects are made of. So when we look at the definition of mass, which is how much matter that is in an object, you just have to imagine that objects are made out of these green circles. So when we talk about mass, it's how many of these green circles are the object made of. That is the amount of matter. So you see in this diagram A and B, A, the square object is made out of 6 circles. When we move it to the moon, the object is still made out of 6 circles. Therefore, mass remains the same. And if we look at the example here, so let's say this box here weighs 300 kg on Earth. On the moon, it will only weigh around 150 kilograms because of weaker gravitational force. So do note and not confuse these two terms. Mass is not the same as weight. Mass remains constant wherever you go, but weight changes according to the gravitational force in the area that you are at. So we see here the moon and the Earth have different gravitational forces. Therefore, it affects the weight, but the mass remains the same. So whatever that I have mentioned to you earlier can be seen by this explanation here. Regardless of their locations, their mass remains the same. Their weight changes because the amount of gravity at each location is different. And what do we know and what do we learn about what affects the amount of gravity? So the amount of gravity is affected by mass of objects and also distance. So we see here Earth greater mass, therefore greater gravitational force. Moon has lower mass, therefore weaker gravitational force. Because the gravitational force is greater on Earth, your weight will be higher. Because there is weaker gravitational force on the moon, your weight will be lighter. Do remember this. This is very, very important. So now we return back to the questions that we are supposed to be able to answer after today's lesson. So firstly, what are forces? They are a push or pull. And we can see this in the different kinds of forces that we've learned. Magnetic force, frictional force, elastic force, as well as gravitational force that you've learned today. So what is gravitational force? It is the force of attraction between objects that have mass. So for example, we use the example of Earth and ourselves. There is a gravitational force between the Earth and us, which keeps us rooted to the ground. So what affects gravitational force? Firstly, the mass of the objects, as well as the distance between the two objects. The greater the mass, the greater the gravitational force. The greater the distance between the two objects, the weaker the gravitational force. So the last question is, why is gravitational force so important? One use is that it keeps things rooted to the ground. Can you imagine how hard it would be to have a meal if you are on the moon? The things that you are eating will be floating around, and it would honestly be very hard for you to eat. So with that, I conclude today's video. And remember that if you are still unsure about anything, just leave a comment or watch the video more than once, because these are very big concepts to understand. Thank you.